Hello and welcome to our presentation of the life of Leonardo Pisano Fibonacci. During his early life, Leonardo Pisano was better known as Fibonacci. Fibonacci was born in Pisa, Italy, around 1175 AD. His father was a wealthy merchant who was posted in modern Algeria. As a child, Fibonacci regularly accompanied his father on his travels, meeting with many merchants and learning about their systems of arithmetics. During Fibonacci's life, he was greatly influenced by other mathematicians of the time. His most recognized work, Liber Abaci, was published in 1202. Fibonacci's second version of Liber Abaci was dedicated to Michael Scotus, another 12th century mathematician. Scotus was also believed to play a part in the presentation of Fibonacci's sequence. Fibonacci was also influenced by manuscripts of the 12th century mathematician Plato. Not much is known about the year of death of Fibonacci. However, it was estimated to be between 1240 and 1250 AD. It was most likely in his birthplace, Pisa, Italy. Fibonacci's most noteworthy accomplishments were his book Liber Abaci, the Fibonacci sequence, the square root notation, and the vinculum used in division. Fibonacci contributed to the majority of mathematical fundamentals in the Middle Ages, some of which we still use today. In his book Liber Abaci, Fibonacci introduced and promoted the Hindu-Arabic numeral system in favor of the Roman numeral system in use at the time. He advocated using the numerals 0 to 9 with place value and demonstrated how to convert and differentiate between the two systems. This system was eventually adopted throughout Europe by the 15th century. The Fibonacci sequence is a series of numbers beginning with 0 and 1, where a real number is found by adding the previous two numbers. Fibonacci made the discovery when he was dissecting the breeding pattern of rabbits. The Fibonacci sequence eventually shaped the world of mathematics as it made way for the Fibonacci spiral. The Fibonacci spiral is a series of connected quarter circles drawn inside an array of squares with Fibonacci number dimensions. Interestingly, any two successive numbers have a golden ratio, approximately 1.618034. This is also applied in the real world, as sunflower seeds are an example of even distribution as a result of Fibonacci spiral. The seeds are uniformly distributed regardless of their size. The golden ratio, represented by the Greek letter phi. Two numbers are in the golden ratio if their ratio is the same number as the ratio of their sum to the higher number. Johannes Kepler was the first to find the link between the Fibonacci sequence and the golden ratio. He proved that the limit of the ratios of successive numbers in the sequence is equal to the golden ratio. Many historical artists and architects proportion their works to fit the golden ratio, believing it to be aesthetically pleasing. Structures such as the Parthenon in Greece and the Great Mosque of the Koronen in Tunisia are believed to contain consistent use of the golden rectangle in their design. Although these structures were built before Fibonacci's time, the ratio was still well known and appreciated. Leonardo da Vinci believed some bodily proportions exhibit the golden ratio, and his works are speculated to incorporate it. Thank you for listening to our presentation, and here are a list of some of our references that we used throughout the presentation.